Hello, welcome to the third critical thinking lecture. Today we'll be discussing bias, and specifically cognitive bias and fallacious thinking. We'll also be entering the first discussion of a little bit of formalism. Nothing major, just enough to make thinking easier for you. So first off, though, we'll start with bias, the various cognitive biases that you might find yourself with. Of course, as we begin with each of our sections, at this point you should take a moment, stop, or perhaps if you've learned from previous discussions, have this video already ready, but go meditate. I want you to do the leaves on a stream. Assuming you're doing that, I'm going to give you a brief summary of some of the stuff we discussed last time, namely a general, very broad, high-level model of cognition that I was introducing you to. Summarizing, we attend to our environments, we encode information into conceptual hierarchies, we form beliefs and desires based on those hierarchies, and then we behave accordingly. That's the broad, high-level picture. There are many ways in which this may result in false beliefs or bad desires, and consequently undesirable behaviors. Now, this is compounded by the fact that we're limited, we're sometimes emotional and affected. Remember, it also discussed, I believe, in the first lecture, the System 1, System 2 thinking. We sort of like have a slow, methodical, calculated way of approaching problems. We, on the other hand, have a very quick, hot, fast, sort of heuristic way of approaching problems. Both have their benefits. They also have their drawbacks. Now, we're spotting these issues, these cognitive biases, and in today's lecture, so we have targets for what to fix going forward, and we're basically going to be able to read off some of these issues from the model of cognition that I was introducing you to in the last lecture. Important for this is attention training. It's sort of like the upstream issue. We don't have a lot of attention, but you can sort of improve it. I've introduced you in a previous homework to the NBAC. The NBAC was originally introduced and promoted as a way to improve working memory. Not clear it does that. Lots of conflicting evidence. What it does seem to do is help you strengthen your attention muscles. And it is really a muscle. So if you enjoyed playing it, good, keep doing it. If you didn't, sorry, keep doing it. But it'll be crucial for strengthening or for your workouts. Now today we'll be examining tools to help you hold a lot of information with little cognitive effort. And this will be approaching issues that arise from memory. But before we get to there, we should identify some of these issues that I'm alluding to. Now, attention. Again, surrounded by all of this info, we're bombarded with too much stimuli, we restrict our attention to some parts of our perceptual manifold, etc. Here, I want to show you illustrating it specifically. Now, watch this video. The point here being this is supposed to illustrate, on the one hand, how good we are at attending to things. I suspect you did a not too bad job at counting how many basketballs were thrown. 15, right? Now, on the other hand, it can illustrate how our selection can be sometimes too powerful. I'm sometimes surprised at how frequently this is duplicated, but most people, from my experience, don't see the gorilla. That can be a good and bad thing. This is, again, attention. Availability. Now, let me ask you this question, just in general. Let's think about this. Are there more words in English that begin with the letter K, or that have the letter K in the third position? Pause this, think about it for a moment. And there are 3 times as many words in English that have K in the third position. Now, most people get this wrong, and it's thought that this is so because rather than attempt to provide actual statistics, readers tend to go with their gut. And the gut says something like, I can think of several words that start with K, but not many that have K in the third position. This is called availability bias. What can you recall from your memory? This is which is just to say you've encoded the relevant information in some hierarchy, according to that cognitive model I've been illustrating, and you're guessing based on that hierarchy rather than reflecting. What does that sound like? If you recall from the first lecture, this is sort of quick System 1 thinking, right? Still, problem. It can go awry. Now, let's think about this anchoring. Let me ask you to illustrate. Do you think the number of African countries in the United Nations is greater than or less than 10? Pause if you don't mind. And now, hopefully you did. I'm going to continue right now. Now, how many African countries do you think are members of the UN? Also pause, think about it. I'm assuming that you have, and there are 54 African nations in the UN. Now, most people will provide a significantly lower answer than 54, given the way this question's set up, and that is because they've been through that numbering primed to think that the actual number is around 10. I suspect this was true of you as well. Anchoring is sort of downstream from hierarchies. You're primed to use new, available information to make guesses. Again, system 1, still problem. Now, these are some problems we should look out for, but there's also, as I mentioned before, ways to train. It's upstream, attending, not much of it. It's going to be part of a strategy for ensuring we don't fall into the various problems observed here. And we can use, as I mentioned, the NBAC to help you. Again, at this point, I'd like you, if you don't mind, to pause. Go play 3 rounds of the 3-back and set the mode at the level of the top before starting. You can read the instructions. You can adjust it to make it as harder as you want. But do me a favor, don't go below 3. We'll start there. We'll work from there. All right. Now, I said 2 sorts of issues, like major themes, were prevalent in this discussion of our biases. One is the attention, and we've got some approaches for how to help you attend better. But another is, as you probably noticed, memory. We're pulling things from memory. We want to have a strong memory. We can't really train memory. NBAC, remember, was supposed to be helpful for that, or at least it was initially proposed to do, or to train something like that, but it never really replicated, didn't give the right sort of empirical evidence to support hypotheses surrounding that, to justify interventions. Nevertheless, we can work on memory in a sort of creative way. And it's like this. Simplify the things, or the way we remember things. That is how we're going to get around our limitations that we have on memory. Logic is actually sort of designed to do that. Now, I don't want you to be confused and think this is a logic class. It is not, although I did mention I'm a logician. I'm not going to try to teach you logic. What I am going to do is try to cull what can be used for you, or useful for you, when you're thinking critically and trying to avoid mistakes in your own life without having to go up in a balloon into the higher reaches of logic. Again, though, we want to pause. We did just see a lot of sort of cognitive biases that many of us are susceptible to, so I think it's important to pause at this point and meditate not on leaves of a stream to center yourself, but loving kindness, care, attend to yourself, because I know you have a lot of failings. We all do, and it's okay, and you should appreciate yourself for your strengths as well. Do that for a moment, come back to me, and we'll continue, assuming you have. Let me tell you a little bit about syntax and semantics. Now, think about this. The word dog, like the literal word, means something like mammal that barks and is adorable and has a tail, etc. So semantics, that's the study of the meaning of words like dog, or terms, or phrases, or sentences. The word dog is a concatenation or a combination of symbols, D, O, and G, arranged in a certain way. That's the syntax. Syntax is the study of the shape of terms. It's the shape of sentences. It's the shape of things like this. So, again, just to make this crystal, syntax is just the shape, the way things are arranged, and semantics, that's the meanings of those things that we've arranged. Now, we use language often to pick out things in environments, and we call this naming. So check it out, dog. Somebody's saying, dog, the shape of the letters differs from the meaning of the term, which differs from the object referenced by the term, right? So here's the name, here's the thing named, and then the finger was doing the naming. You see this by observing the difference between the use of a term and the mention of a term. Like, this is a common sort of thing that logicians and philosophers like to point out, this difference between use and mention. So dog has 3 letters. But a dog, like Scruffy, doesn't have any letters, right? It's a dog. Now, this might sound silly, but this is like mistakes based on use and mention actually have caused a significant amount of like economic problems, especially once at the advent of the computing age. I work in a field of applied ontology, which is basically like being careful about how you code information into databases, you can think of. And one of the reasons why this field exists is because in the early heyday of computing, when people were gathering lots of data about, say, human beings, people, they would not be paying attention about how they were like coding that information into databases. And the result was that in many cases people would be included in databases and classified in terms of a social security number. So to represent me in a database, for instance, it would have my social security number. But then they would like run automated reasoning machines over this sort of databases and end up saying things like John, me, is divisible by a number, which is silly. I am clearly human and not a number. But if you think of me and the database did as a social security number, then of course I'm divisible by a number. The issue here being that computers are dumb, and we have to tell them exactly what to do because they don't really understand semantics. They do understand the syntax. That's how most computers work. Okay. The use of this, the use of the term, is seen in this second expression. The mention is here with the actual shape, like right. So again, this use and mention distinction can be illustrated just by this. Now, we said that the extension of a term is the thing, the object, or the objects referred to by the term. So a moment ago I said the extension, or when I was pointing to the thing name, the extension of dog is the set of all dogs, right? Like if you're just pointing to a single dog, it would be that dog. That would be the extension. Just like the extension of the numeral 1 is the number. That's the thing it refers to. Now, syntax and semantics differ in important ways, I'm sure, as you've seen, but they're subtly interrelated. You can surprisingly extract meaning from the shapes of terms, even when you don't know the meanings of the term or don't know the semantics. Let me illustrate with a little bit of a puzzle. Now this will have you venture off for a moment away, but it'd probably be quite challenging if you do. We're going to do more of this in class, but just to anticipate, have a taste of the Go stack. You can follow the link accompanying this video to this game. It's a text game. Your task in this game is to ask questions and to learn a language. Here is the opening. Finally, you're here, blah, blah, blah. And you can probably see already at the Delcott of Tondam, where Dosh is deep. You don't know the language. You're just entering here and you're trying to figure things out. Now, this is just the intro. Don't get confused. You're giving this information. Crendon Loft Lut are 5 clouds. You can see clouds. They're camlings. Not sure what those are yet, right? You can input questions here at this little caret, and just so you don't think that you can cheat with the help file, this is the help file. So good luck. And basically you'll ask questions and the game will tell you if you're on the right track or not, and you can use its answers to learn information about how the language works. And this is all at the level of syntax. So basically you're going to be figuring out what words mean without knowing what they mean, just based on how they're arranged. Now, to give you a little more background just on sort of way sentences are structured, and then we'll close by giving you an illustration, just a very brief illustration on how you might infer information in that syntactic way I was just alluding to. Here we'll talk just for a moment about a straightforward way to talk about the meanings of terms is by considering what they refer to. We've been doing that several times up till now. We can also say what a given sentence means by considering all the things the terms in the sentence refer to. For example, the grass is green means something about this grass and a color. And it's true just in case grass is in fact green. That's just what it means, right? This sort of meaning is often understood in terms of truth. I just used the word true. So this is just to say that the grass is green is true just in case the grass is green. Like this is almost too trivial to state, right? This is what we call descriptive sentences. They're sentences that putatively describe things, and they can get that right or not. That is to say, they are true or false. This is fun, but note we like to spend time talking about different sentence types because not all sentences are descriptive. Some don't have anything to do with truth at all, but they still have meaning, and we want to be able to talk about that. Here's some examples. Close the door. It's neither true nor false. It's a command. Same for chili is delicious. It is. That is in fact true. But if I'm using the sort of sense I'm intending here is that I'm just expressing my love of chili. I'm not, when I say chili is delicious, saying that my sort of taste buds are such that I find chili delicious, as a matter of fact. What I am doing instead is telling you, or anybody who will listen, that chili is delicious. Now, same for it's getting hot in here with a question mark. This is a question, clearly. They all have meaning. None of these are true or false, though. That's not the sort of conveyance. The first here is imperative or command. The second is expressive. As I said, this question, sometimes we call that interrogative. Those are the various sentence types. Part of the reasons they have meaning independent of truth stems from the fact that they have specific context. Note, there's our specific syntax. The first sentence, if you note, has an exclamation point indicating it's an imperative. Chili is delicious. This can kind of mask as a descriptive, so that claim I have at the very bottom is not exactly correct with respect to that. But nevertheless, 2 out of 3 ain't bad. The question mark for interrogatives is a syntactic way to indicate that it's not a description. Now, getting back to the Gostack and delving just a little bit into inference and what logicians actually study, preserving truth from sentence to sentence is sort of a topic that logicians have found useful. We're doing it here, again, not because we're doing logic, but because it's a great way to minimize information that you have to remember. It's a great way to sort of like lower the cognitive load on your memory. Now, here's an example, sort of like a paradigmatic example we'll use for what logicians call modus ponens, which is a sort of way of thinking how sentences have to be connected. And you'll see in a moment why this might save you some time. So here's an example. John goes to the store, then John buys milk. John goes to the store, hence John buys milk. Now, if the first 2 sentences are true, then the third one has to be. It's sort of like we don't really even need the third one. It's just contained, you might think, in the first 2. We get it for free. This is solely due to the shape of the sentences involved. This is solely syntax, okay? The rule underwriting this, as I said, is called modus ponens, and it has this form. This is purely syntax, right? If A, then B, A, therefore B. You'll never go wrong if you hold that B is true given the first 2 sentences. There is not a counterexample to this. This is always true. Keep it in mind, right? Similarly, you can infer information from the Gostack language based purely on the syntax of sentences. For example, a sentence that uses the term distems before the dashes plausibly suggests this term is a verb. It is doing something. Distemming is a thing done. And if for any dash, the Gostack distems that dash, and X is a dash, then the Gostack distems it, and that's just logic. Now, going forward, we're only going to be learning enough logic to again, like minimize the sort of cognitive load on your working memory, short and long term. I want to leave you at this point with some motivation that I find for approaching critical thinking this way. It's from John von Neumann. It's a very famous computer programmer, logician, basically a Renaissance individual, knew many things about many areas, contributed quite widely into intellectual fields, one of the last real Renaissance individuals, given his breadth of knowledge. He was once asked why, how is it, how does he know so much about so much? And he would say that what he does whenever he's trying to learn something new is go to the textbook, look in the back, and try to find all the logic. Now, most books aren't written that way, of course, but he was basically saying, look through the book, look for summaries of it, etc., and try to find the basic structure of the discipline. Like, try to find the basic structure of biology, just the basic structure of chemistry. And once you see that, then you can see the patterns. And once you can see the patterns, you don't actually have to remember that much, because you can always reconstruct it from the patterns. The case in point here, if Garfield steals lasagna from John, then John will be angry. Garfield steals lasagna from John. I don't actually have to know anything about the content of the sentences, about John, about Garfield, about lasagna, to know that it follows that John will be angry from those two. Again, just syntax. Now, this probably seems a little too simple to even be worth stating, but as you'll see, we'll be exposed to a few more sophisticated logical principles that'll help save you a lot of time.